Hi, welcome to a video from Math 1 for section 2.2, which is looking at patterns and linear functions. So let's start with some vocabulary. So first of all, we have independent and dependent variable. They obviously relate to each other. The dependent variable is the output of a function, and it is the variable that changes in response to the independent variable. The independent variable is the input of the function. So you can see over here we've got this function machine, which you may have seen before. So the input goes in, the function changes it, and then we get an output. Okay, so the independent variable is that input, and that variable is the one that changes the dependent variable. Okay, so go ahead and pause it if you need to copy it down, and then repause it when you're ready. Okay, so the next thing we want to talk about is what is a function. Now, a function isn't just when something happens to a number and we get a new number. It has a very specific definition. Specifically, a function is a relationship that pairs each input value with exactly one output value. All right, the keyword there is exactly, like as keywords, is exactly one. So what does this mean? This essentially means that for each input, remember, which is the x, there's only going to be one output, which is the y. So if you plug in a number into this function, say 5, and you get out another number, say 7, and you only get one, you're good. But let's say instead of getting 5 or plugging in 5 you get 7. Let's say you plug in 5 and you get 7 and you get 2. That would not be a function because it doesn't match with exactly 1. It exacts with 2 outputs. Okay? All right. So let's talk about what a linear function is. A linear function is a function whose graph is a non-vertical line or part of a line. Okay? So all functions have a graph associated with it, and the graphs are created by looking at the ordered pairs. Okay, so an ordered pair you may know better as a point. And the ordered pair is determined by the input, which is x, right? The input into a function, and then it gets matched with the output, which is the y. Okay, so let's just briefly review some things about the coordinate plane, which is where we graph things. Okay, the input, the x, we have the x-axis, so that's this line right here. It's like a number line. We've got 0 in the middle, we've got positive numbers on the right and negative numbers on the left. Okay, and then we have a vertical number line, which is the y-axis, which is where the outputs are, or where we're going to match up the inputs and the outputs. Okay, so the positive numbers are going to be on the top and the negative numbers are going to be on the bottom. This point in the middle is called the origin, where they meet. Okay? Alright, so let's do an example of a linear function. Okay? One way that you can tell something is linear by looking at a t-table. So I'm going to give you a t-table of points. One way that you can tell something is linear is that the x and y both change at a constant rate. Okay, so I'm going to add that to this definition up here. The x, which is the input, and the y change at a constant rate. And that's what creates the line. Okay, so for example, I'm going to give you this function. Let's say we have y equals negative 2x plus 6. Now, in later sections, we will be going over how do you create this t-table a little bit more in detail. That's in section 2.4. But for right now, I'm just going to make the t-table really quick and then show you how this creates a line. Alright, so essentially what I'm going to do is I'm going to plug in some numbers. So I'm going to plug in a bunch of numbers. You can't plug in every number, so you have to pick and choose. So I'm going to choose 0, 1, 2, 3, 4. So essentially what I'm doing is I'm putting the 0 in as an input for x. And I'm figuring out what the output is. This is going to give me 6. Alright, and then I'm going to do that for each of these. So I'm going to plug in 1. This is going to give me 4. I'm going to plug in 2. This is going to give me 2. And 3. This is going to give me 0. And 4. This is going to give me negative 2. Alright, so I have my inputs, which are my x's right here, and my outputs. And so now let's plot the points and see what if we do get a line. Okay, so 0, 6. If you prefer it as a point, 0, 6. So I'm going to go over 0, which means I'm going over left or right nothing. I'm staying right here where there's a 0. And I'm going to go up 6. So up 1, 2, 3, 4, 5, 6. So that's on the y-axis. And then we're going to go 1, 4. So starting at the origin, going right 1, up 4, putting a dot, 2, 2, 3, 0. So 3, 0 is I'm going right 3 on the x-axis and I'm going up and down on the y-axis nothing. So does it look like it's making a line? I think so. And then there's one more point, 4, negative 2. Yes, it's making a line. So we can go ahead and connect the dots with a line. Okay, so let's go back to this idea that I said where x and y change at a constant rate. So let's see, how does the x change? So I have 0, 1, 2, 3, 4. So I deliberately made it so I'm changing up by 1 each time. I didn't just pick random points. Okay, so when you pick numbers like this, we're testing to see if when their constant is the y constant. So as the x goes up by 1, hopefully the y is doing something each time that's the same. It's changing at a constant rate. So let's look at the y's. 6 to 4, that would be subtracting 2. 4 to 2, we're subtracting 2. 2 to 0, we're subtracting 2. So it looks like we're having a constant change of subtracting 2. So in general, with a t-table, we can see that, yes, this is a linear function. X and y are both changing at the same, they're not changing at the same rate, but they're changing at a constant rate. Okay, so these all match, and these all match. Not that they match each other. Okay? Alright, let's look at some examples. I've got 2 examples of some phenomena, some word problems that are going to be linear. Okay, so we have a diagram. It says in the diagram, what is the relationship between the number of rectangles and the perimeter of the figure they form? So let's take a look at this picture and see what they're talking about. Okay, so the number of figures, so we have one rectangle, number of rectangle. So this is one rectangle. We have it's 6 by 1, which also means that this is 6 and this is 1, right? Rectangles, the opposite sides are the same. Okay, here we've got 2 rectangles next to each other. So this is 6, and then this is 1 and a 1. All right, now we have, whoa, sorry about that. We have 3 rectangles. We have 6 and a 6 on each side, and then we have a 1 and a 1 and a 1. Obviously we can add up all these ones. And then we have 4 rectangles. We have a 6 and a 6 and a 1 and a 1, so we have 4 ones here. Okay, so let's make a table just like we were just doing before. Okay, a T-table. On the left, let's put number of rectangles. Abbreviate that, okay? And then on the other side, let's put the perimeter. So I'm choosing to make the number of rectangles my independent variable because the perimeter is going to change depending on how many rectangles we have. How many rectangles we have does not depend on the perimeter. Okay, so the number of rectangles we have in this picture is 1, 2, 3, and 4. All right, let's go ahead and calculate the perimeters. So when they say perimeter of the figure, they're talking about the complete outside perimeter. So let's see. Here we have 6, 6. We have 2 6s. So we could do 2 times 6 plus 2 1s. That's 12 plus 2, which is 14. Okay, let's look at figure 2. So we're looking at this outside perimeter. So you'll notice again we have 2 6s. So I'm going to do 2 times 6. Let's see how many 1s we have. We have 1, 2, 3, 4. 4 1s. So that's 12 plus 4, which is 16. All right, let's keep going. In fact, why don't you go ahead and do 3 and 4, and then unpause the video. So pause the video, do 3 and 4, and then unpause the video when you're ready. All right, so for the perimeter for figure 3 with 3 rectangles, we have 18. We had 2 times 6 plus we had 6 of those 1s. And then for figure with 4 rectangles, we had 2 times 6 plus 8 times 1. So let's see if we can come up with a pattern. Notice that there's always 2 6s. That never changes. Okay, so let's say we have X rectangles, so an unknown amount of rectangles. What would the perimeter be? Okay, well, I think that there is going to be a 2 times 6, which we could just write that as a 12. There's always going to be at least 12. Okay, because there's those 2 6s. So, but the 1s are the things that are changing. So the 1s, let's see, here we had 2, 4, 6, 8 1s, which we don't really have to multiply by 1, doesn't do anything. So it's really the 2, 4, 6, 8 are the important numbers here. So what's the relationship to the, what's going on? Where are these 2, 4, 6, 8 coming from? Well, if you'll notice, the number of rectangles, if we multiply that number times 2, that gives us how many 1s we have. And that's because there's 2 1s for each rectangle, 1 on each end. So we could say that there's 2x. So 2 times x. So 2 times x will give you how many 1s there's going to be, which is going to equal your perimeter, which is going to be the output, which we can use y for. Okay? All right, so let's do a graph. Or actually, we just created an equation, so let's list these off. We did the table. We need words, an equation, and a graph. So let's do words. Okay, so I think I'm going to type this. If it'll let me. There we go. So the number of rectangles times 2 plus 12 equals the perimeter. All right, in an equation we have that. We're just going to write it separately. It's this guy right here. It's y, which is the perimeter, equals You could do a 2x plus 12 if you prefer, or you can keep it 12 plus 2x. Either one's fine. All right, finally, let's look at the graph. We have two axes here. The independent one, which is our x, is the number of rectangles. Then the y axis is the perimeter. Okay, so let's see what we need these to go by. So the number of rectangles can just go by one. So one rectangle, two rectangles, three rectangles, four rectangles. So this is 1, 2, 3, 4. The perimeter, we need to get it up into 20. So maybe we should go, let's see, by twos. Let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So let's go by twos here. Now let's plot our graph, our points. So one rectangle is a perimeter of 14. So over 1, up 2, 4, 6, 8, 10, 12, 14. Two rectangles would be 16. Three rectangles was 18. Four rectangles is 20. Okay, does it look like it's a linear function? Does it look like it's making a line? It does. This is definitely a linear function. But one thing I need you to understand is we don't want to connect the dots in this case, because it doesn't make sense to have a decimal number of rectangles. Like you can't have 1.5 or 1.2 rectangles. So we don't want to connect this. But some problems don't make sense to connect, and this is one of those cases. By the way, when you don't connect it, this is called a discrete graph. Okay, let's look at one more example of a linear function. Okay, why don't you go ahead and try this one on your own? Pause the video, read through it, give it a try, and then unpause the video to see the answer. Actually, I'm going to give you one little hint here about how you should do this graph. Since our y here is 503 to 512, we don't need to label all of the graph. So we don't need the y-axis to be labeled for 1 through 512. So there's a little thing that you can do when you're labeling it and you want to skip a bunch, is you just put a little squiggle here. You see on the y-axis right here, there's a squiggle. Whoops. Okay, that squiggle right here means you skipped some. So that can save us some time. So go ahead and label your graph like this, okay? All right, go ahead and pause it again, finish this problem, and unpause it when you're ready. Okay, so the first thing I did was I plotted the points on the graph, although it got shifted a little bit. There we go. And you should know that it is linear and it's going down. So at 0 photos, there's 512 megabytes of memory left on your memory chip. One picture, there's 3 less, there's 509. Two pictures, there's another 3 less, so 506. And so it's going down by 3 megabytes each time. So to create an equation, think about what you're starting with. We're starting with 512 megabytes. So no pictures are taken, that's what it starts with. And each time a picture is taken, you're going to lose 3 megabytes. So we're going to subtract 3 times x. Remember that x is the number of photos taken each time. Okay? So you can write it in, so they want you to write it in words. Starting at 512, subtract 3 for each photo taken. You can think of it that way. Or you could say 512 minus 3 times each photo, something like that. Okay? All right, that's 2, 2. Next video will be about 2, 3.